Okay, then here is the challenge question for the end of chapter 12, mixed, exercise 12 there. So it says find the first four terms in the binomial expansion of x plus h to the power 7 in ascending powers. So we are going to have, what are we going to have? We're going to have 7 to the 0. We're going to have 7 to the 1, 7 to the 2, and 7 to the 3. There we go. We are then going to have x to the power 7, x to the power 6, x to the power 5, and x to the power 4. And then we are going to have h to the power 0, h to the power 1, h to the power 2, and h to the power 3, which gives us then x to the 7 equals, right, what's NCR of that? So what is it? 7, 1. So 7 NCR 1 is 7 x 6 h. 7 NC2 is 21 x to the 5 h squared. And finally NC3 35 x5 x4 h3. And so writing it out for the first four terms is going to be x plus h to the power 7 is equal to x to the 7 plus 7x to the 6 h plus 21x to the 5 h squared plus 35x to the 4 h to the 3 plus ... Good. Now then, part B. Part B. Hence prove from first principles that the derivative of x to the 7 is 7 to the x6. So we want to differentiate x to the 7, so we want to differentiate that with respect to x. And it's going to have a limit of the h tending towards 0, and the formula that we need to use is f of x plus h minus f of x all over h, and so we end up with the limit as h tends to 0 is equal to x plus h to the power 7 minus x to the 7 all over h. And so as we multiply that out, the limit of h to the 0, we're going to get x squared, x to the 7 plus, using the binomial expansion that we've done just up here, x to the 7, 7x to the 6 h plus 221x to the 5 h squared plus 35x to the 4 h 3, and minus x to the power 7 all over h. Okay. And so, as we take that, we can tidy it up a bit. X to the 7 and x to the 7 cancel each other out. So we have the limit of h to the 0. So this one cancels with this one. And then we get all of these and we divide them by h. So they become 7x to the 6 plus 21x to the 5h, h squared changes to a h, plus 35x to the 4h squared. Okay, and now as it tends to 0, okay, so as h goes to 0, we are left with 7x to the 6 plus 0, because we're multiplying by h, plus 0 squared if you want, because it's the h squared, which means we were left with the differential of the x to the 7 with respect to dx is equal to 7x to the 6. And that's the first principle of it. Ultimately, as always with these things, it's taking your function, which is taken away, and doing a plus h, cancelling through by the h's, and then hopefully ending up with what you need. Okay, that's the end of chapter 12. Hopefully on to chapter 13 very soon.